Welcome back, my dear friends and dear students. A very good morning, good afternoon, good evening to all of you. And as you know, this is the DADM2, which is Data Analysis and Decision Making 2 course under NPTEL MOOC series. And this total the course is for 12 weeks, which is for 30 hours, and each week we have 5 lectures, each being for half an hour. So, we are in the 17th class. 17th class means we have already completed 3 weeks, and in the second class for the 4th week. And as you know, you were discussing about data envelopment analysis, data envelopment analysis being a non-parametric technique, where you basically use a very simple concept of linear optimization concept, and but based on the fact that the initial problem has been formulated as a ratio of an for input output to get an efficiency, based on the fact that whether it is an input oriented model or an output oriented model, and then you basically try to solve it using optimization problem, but before that you convert it very simply into a linear programming problem, a very simple case. And if you remember, I have been mentioning time and again that whether you take the efficiency or the inverse of the efficiency, you have to either maximize or minimize depending on how you look at the problem, and if it is an output oriented model or an input oriented model, you basically formulate in such a way that you normalize either the numerator, where the numerator is basically the output, or normalize the numerator where the numerator is the input, depending on how you are trying to analyze. So, if it is input being normalized, that means you will fix input at a level of 1 and try to increase the output, and if you basically keep the output fixed at level of unit 1, normalized it, then you are basically trying to reduce the input. Now, we were discussing that problem the last class, the formulation of a problem where they were basically 3 DMUs, k is equal to 1, 2, 3, capital K is equal to 3. They were basically 2 inputs and there was only one output, and we are formulating it using the concept of output oriented model. Now, we will basically consider the input oriented model. So, I will follow the same scheme of coloring. So, it will be easy for you to understand. So, consider that you have an output oriented model and input oriented model. So, in the input oriented model, what you are trying to do is basically trying to minimize a ratio. Why you are trying to minimize the ratio? Because you are trying to take the inverse of efficiency, and taking the inverse of the efficiency would mean that you are putting the output and the input in such a way that the input would be in the numerator and the output would be in denominator, and try to basically normalize the output at a level of 1 and try to basically decrease the input as low as possible to minimize it, because minimizing would basically bring down the numerator as low as possible. That means, it will actually increase your efficiency for the DMU. So, for as there are basically 3 DMUs, that is DMU 1, 2, 3, which are 3 machines. So, we will basically formulate the problems accordingly, because formulation would be more important and then solving it will be very simple optimization problem. So, in the first model, this you have the objective function and this is the minimization. So, remember that. So, I will try to highlight the minimization, even though I did not highlight it the maximization in the last class, but I will try to highlight the word minimization in each and every step. So, I will basically highlight it using the red color. So, I am trying to basically minimize, and the minimization would be done for the case. So, this is the objective function for the first DMU, for this first DMU. So, this should vanish. So, this is the for the first DMU, and what do you have for the constraint? So, now if you remember, for the input oriented model, the constraint was basically formulated accordingly. I will write the general the way how you formulate or write the constraints. It was basically input by output was greater than 1. So, in the output oriented model it was actual efficiency which was output by input less than 1. Okay, no, I should use a different color because I was using the black one. My apologies, please bear with me. So it was basically the input divided by output is greater than 1, then input is greater than output, then input minus output is greater than 0. So this was general one, and you have 3 DMUs, so there will be 3 equations, which are equation 1, equation 2 and equation 3. So these are corresponding to the first DMU, the second DMU and the third DMU. Now, if you consider the objective functions had already been done. If you consider the constraints, so I will basically use the coloring scheme as same as I did for the output oriented model. So, for the first DMU, the input and an outputs would be denoted likewise. So, this is the combination of the input and output, where 10 and 2 are the corresponding units which are basically, or the conversion rates which are being used for the input, and that 100 is basically the conversion rates or the units being used for the output. Similarly, when I go to the second DMU, I use the coloring scheme as orange, which I have already done. So, correspondingly 8, 4 and 80 are the conversion rates or the units for the inputs, which are 2 inputs and for 1 output. Similarly, when I use the coloring scheme green, which I had done it in the last class. So, 12, 1.5 and 120 are the corresponding conversion units or multiplicative factors being used for the inputs and the output, and the weights which were basically u, I, k and v, j, k, where I is basically the number of inputs ranging from 1 to capital I, j is the number of outputs ranging from 1 to capital J, or m and n, whichever you know. I think we have taken m and n. So, m would be the number of inputs. So, I would basically range from 1 to capital M, j would basically range from 1 to capital N, and k, which is basically the number of DMUs, would basically range from 1 to capital K. So, you had 2 inputs, 1 output and 3 DMUs. So, we will use the same coloring scheme, the dark blue. So, this is the number of inputs, number of outputs and the DMUs. So, we have been able to at least give the initial formulation for the objective function being there for the first DMU, and this being for the the optimization problem for the first DMU, and this is an input oriented model. Now, let us go for the second DMU, which is the second machine. Again, we will use the same coloring scheme. So, this is the objective function. So, we will mention it very explicitly. Objective function for the second DMU, and this is the minimization problem. So, I should highlight it using the red color, which I have not done in the last class, but I am trying to make it much more explicit. Now, if you go, it is basically the input by output being greater than 1, input being greater than output, because I am taking it to the right hand side. So, input minus output is greater than 0. So, these three equations are coming for the first DMU, for the second DMU and for the third DMU. So, this is for the first, this is for the second, and this is for the third. So, you have basically giving you the same way how I denoted for the first DMU. So, this is the first, second, third. Then when I again come to the coloring scheme, the conversion factor of 10, 2 and 100 are the respective first two being for the inputs and the last one being for the output for the first DMU. Then 8, 4, 80 are the corresponding units, conversion factors or multiplicative factors for the second DMU corresponding to the inputs, which are for the first two, which is 8 and 4, and the last 80 is for the outputs. And then when I use the last coloring scheme, so the multiplicative factors are 12, 1.5 and 120 corresponding to the two inputs and one output for the third DMU. And again the weights are given by u and v with the corresponding suffix with respect to I k and j k. I is basically in the nomenclature being used for the inputs, j being the nomenclature being used for the outputs, and k is for the DMUs. And again you have two inputs, one outputs and 3 DMUs. Now, let us go to the third DMU formulation. So, this is the objective function for the third DMU, and again this red color highlighting the fact that is a minimization problem. Now, actual formulation is input by output being greater than 1, input greater than output, input minus output is greater than 0. So, they are being utilized for the first constraint, which is for the first DMU, the second constraint which is for the second DMU, and the third constraint which is for the third DMU. So, this is the first, this is the second, and this is the third. Now, if I consider again the same coloring scheme, sorry, this I should use a highlighter. So, the 10, 2 and 100 are the corresponding first two being for the input conversion factor or the weights or whatever you try to denote for the first DMU inputs, and for 100 being the first DMU's outputs. Correspondingly, 8 and 4 are for the inputs for the second DMU, and 80 is basically the output related conversion factors for the second DMU. Similarly, 12, 1.5, 120 are the corresponding inputs conversion rates, first two 12 and 1.5 and 120 being for the outputs. Then again the weights which you want to find out are given by u and v with the corresponding suffix. So, I will denote the color which is basically dark blue. Now, this was the initial formulation. Now, I will basically utilize both the input oriented model 3 formulation for the case when we convert them into the actual linear optimization problem. So, I will go one by one, first DMU, second DMU, third DMU. So, if you remember, I have repeated it time and again, but I will still repeat it in order to make things much clearer for you. For the DMU 1, we had similarly for DMU 2 and DMU 3, we had taken the case where you are trying to minimize the overall factor, which in the numerator you have the input and the denominator you have the output. Now, we are forcefully putting the outputs as normalized as 1 and try to minimize the input as low as possible for all the 3 DMUs. So, now based on this fundamental principle, we will again give the newer version of the optimization problem which will now be linear. So, let us go through that. So, if you remember, the numerator had that leave the minimization word. In the numerator you had basically the weights multiplied by the conversion factors for the inputs for the first DMU. So, obviously, we will try to minimize that corresponding to the fact that the output which was in the denominator is being forcefully made as 1, and that will come later on. So, this would be the minimization one. So, this is the objective function which I will denote. But in this case, remember, this is linear formulation. This is the linear formulation which is doing for the first DMU. So, because we have done away with the denominator. Now, corresponding to the fact that we have been able to convert them the constraints. So, the constraints had already been given by the formulas. You remember, I just write it down again. This is 0. So, this part, the last part, actually is now being utilized to convert the constraints. So, this is the first, this is the second, this is the third. They would want extra one, I will come to that. So, this is the first, which was already there, we are just converting to linear part, and actually we are utilizing the one here. Why I am highlighting it? Because like in the minimization word, this is also important that I am trying to utilize input minus output is greater than 0, and I am trying to utilize for the all the first constraints, where I am just hovering my electronic pen. Now, if you remember, so obviously let me come to the fact. So, the color schemes are 10 to 100 for the combinations input output for the first DMU, 8480 is the combination of input output for the second DMU. This is the conversion rates, and 12 1.5 120 is for the conversion rates for the third DMU. Now, the denominator which has been forcefully put as 1 is now coming up as an added constraint corresponding to the fact that I am using the first DMU to minimize it. So, obviously, this will come here. So, this part is the extra one which I am getting corresponding to the DMU 1, and obviously, there would be, when you formulate it for DMU 2, DMU 3, there would be such problem formulations coming out in the constraints. I will highlight it with the same red color, and as usual I is equal to 2, I is equal to 1 and 2. So, there are 2, j is equal to 1, k is equal to 1, 2, 3, and the weights are u and v. Now, let us come to the second DMU. I will use the same coloring scheme again. So, this is the objective function for second DMU. This is a linear optimization. So, I will use the same word what I would, let me see what I have written. it was linear optimization or formulation. So, I should remove this word for I should use formulation. And here the constraints for the first three, it was input by output being greater than 1, input greater than output, input minus output is greater than 0. So, I have converted that accordingly. So, these are being utilized for the first, the second and the third. And the last constraint, which I will mark by red color, this one is coming from the fact. So, if you see this formulation, they are coming from the fact that I am considering the objective function corresponding to the second DMU being put to or normalized to a factor of 1. So, this is the one, and again the corresponding color scheme brings yellow for the first DMU, orange for the second DMU, green for the third DMU. So, as I am doing it, watch the color scheme, it is exactly the same, and I is equal to 2, j is equal to 1, k is equal to 3. Now, let me come to the third DMU. So, this is the another thing which I should have done it. So, it will be make things clear for us. I should have highlighted the word minimization here. So, I should highlight the word minimization here also. So, this is becomes objective function third DMU, which is linear formulation so this is the linear formulation which is being done. And if I consider again same scheme, input by output being greater than 1, input greater than output, input minus output is greater than 0. So, these three have been done using the corresponding concepts. So, this is the first, this is for the sorry this is for the first, this is for the second, this is for the third. And I should also mention, because I did not mention, let me check how I can do it. I should have mentioned in DME 1, 2, 3. So, technically this one I will use the color red. So, this was basically coming out from here, which is also corresponding to the third. So, this is the in the objective function, the denominator is being shifted here because we are normalizing it. So, similarly this should have been there, the third. No, my mistake, just wait on, wait. This would be for the first, because it is the first DMU. Similarly, this would be for the second. So, 1, 2, 3 are all the constraints existing both in a nonlinear part and the linear part. Only the added on constraint which is coming up is corresponding to the DMU where we are trying to optimize. Similarly, the color scheme are yellow for the first, then orange for the second, first second means the DMU, green being for the third, and this color of red is basically the added constraint which is coming corresponding to the fact that is coming for the third DMU, and obviously U and V are the weights, and the coloring schemes remains the same, which is I is equal to 1 2, j is equal to 1 and k is equal to 1 2 3. I will just discuss one problem and then go into the objective formulation for the this input output oriented model. So, consider the problem is considered that you are a CEO of a company which has 4 factories in different parts in India, and all of the factories produce the same set of products which we denote here by the inputs, but in different numbers. So, they are given as follows. So, you have for factory 1 which is DME 1, you have basically 4 inputs, 3 outputs. So, I would change from 1 to 3 4, J will change from 1 to 3, and obviously K will change from 1 to 3 4 because there are 4 DMUs. Similarly, for second factory inputs are given, I am not reading the values. So, inputs are given, we again 4 inputs and 3 outputs, and this is the second DMU. Similarly, when you come to the DMU 3, inputs are 4 in number, outputs are 3 in number, and for the fourth DMU it is inputs are 4 in number and outputs are 4 in number. So, I will just formulate it very fast. Once you have understood it, I will do just spend 2 minutes or 3 minutes on the formulation for this problem in the next class, and then immediately go into the other topics related to DEA in simple format, and then come to the solution later on when we do the simple optimization problem. With this, I will end this second class in the 4th week, which is the 17th class, and continue discussing more about DEs in the later part. Have a nice day and thank you very much.